Welcome to our lecture online. There's nothing like a simple example to help us understand certain concepts. In this case, the coupling, the mutual coupling coefficient. And we have the equation up here. We know that M, the mutual coupling, is equal to the coupling coefficient times the square root of L1 times L2. So here we have a simple circuit. We have L1, 5 henries, L2, 4 henries, and we want to find the coupling coefficient. We're also told that the mutual coupling is 2.5 henries. So taking that equation and solving that for K, we get M divided by the square root of L1 times L2. All we have to do is plug in the values. So this is equal to 2.5 divided by the square root of L1, which is 5, and L2, which is 4. So that gives us a square root of 20. So 2.5 divided by the square root of 20 is 0.559. So that's equal to 0.559, which is a fairly strong coefficient, a very strong mutual inductance. And so therefore you can see that that is how it's calculated. So, but you can already see that by the fact that here you have 5 and 4 henries, and that the mutual inductance is 2.5, which is more than half of this inductor and half of that inductor. So you'd expect a coefficient that's probably slightly over 1/2. And that's kind of the way you can get a feel for it by simply comparing the size of this, the mutual inductance, to the inductance, self-inductances of the two inductors in the circuit. But that is how it's done, and that is what we mean by the coefficient, the coupling coefficient when we have mutual inductance.
Do a 2-minute video.
2 minutes? All right.